All right, welcome back. When we left off, we had finally created a command over here to quit the game. And what I did for that command was I just did a YY abort. Well, we don't really want to do that. I did that very quickly just so that we could show it actually quitting the game. We're going to fix that up and start building up a command structure now in our abstract syntax tree. So let's come down here, and we're going to create two classes. The first class that we're going to create, we're going to call it a context. Ultimately, this context class, which will be based on a public node, ultimately this context class will contain all the necessary data about our game at any given time. But we're just going to leave it empty for the moment. This is so that we can put it in as a placeholder. And we'll fill it in as we start building up the game. So the next one that we need is going to be called a command. And it's a base class, also based on node. Oh, wait a minute. You know, this context does not get based on node. I'm sorry. It's just a context class. Our command is based on node, and it's going to have a public virtual function called execute that takes a context pointer and is abstract. So all of our commands will be based on this, and they'll have to have an execute and accept a context. All right. So what do we need for a context? Well, one of the things that we need in our context, and our context is just going to be, I could do it as a structure, but I like to use class. We might put some other things in here, and I just like to use class rather than struct. But we're just going to create some public fields. So the first one is going to be bool, and we're going to call it running. And so our main functions are going to have this context, and they'll be able to pass it in, and it'll do something. Okay. So if we have a class called, we'll start our commands with command, and we'll call it quit, and it's going to be derived from public command, which is a node. It's going to have a public, and we're going to have a constructor. So command, well, no, this doesn't even need a constructor. It just needs to be there. So we are going to need to do, let me move this back here, virtual execute virtual, this should be virtual void execute context pointer context. And what it's going to do for quit is it's going to go context pointer running equals false. So when we call execute on this quit command, it's going to set running in the context to false. So how do we use the context? Let's go over here to main.cpp, and here in running we will just create a context, and we'll get rid of this running, and we'll go context dot running equals true. And here we'll say while context dot running. And we'll get rid of this. And what we'll do after we, instead of printing out these nodes, we really don't want to do that. We might print something for some results, but that'll happen inside execute. We get this result back. We'll go. Actually, let me back that out. Instead of printing it out, this is what we still want to go through the nodes, and we want to see if they're a command node. So actually, let me go back to the AST and think about this logic. We can have this command node, and that's fine to organize things, but this execute, I'm going to move up to node. And what that means is I'm going to have to go to this one here and also put it in here and actually implement it, but it doesn't need anything. You can't execute a literal value, so it'll do nothing when it executes a literal value. But when it executes a quit command, it will do something. So now we go back to main, and all we do is go node pointer execute ampersand context. So we're going to send in the address of our context to this execute function, and it can update it and do things within that and manipulate it when we execute these nodes. So let's see what happens now. You know what we'll do over here in AST on this for our execute? We will do something now. We'll go standard C out from this pointer to string from standard end out, so that if we do type in an expression that comes up with a literal value, it'll just print it out when it executes it. So that kind of cleans that up. Let's hope I didn't make any errors, and I did. What did I do wrong? Context has not been declared. Oh, that's simple. We need to move, now we move that function up, we need to move context all the way to the top, which actually is better anyway. This context is a high level thing. It should be at the top. And we're missing a semicolon. Okay, that's usually pretty easy to fix. Here. Oh, yeah, missing a semicolon on that class. Okay. Make, and it built. Okay. So let's go over here and run it, and it should pretty much work as before. 2 plus 3, 5. 5 times 7 times 2 plus 4. And if we type in quit, we don't quit. Okay. Let's go back here. Context pointer running equals false. Instead of a pointer to context, I'm going to return it. I'm going to have that execute take a. I'm going to have execute take an take a reference and we'll have to have it take a reference here. It doesn't care about the context, and this will now be dot running equals false. And over here in main, I'm going to take this out and just pass context as a reference. Okay, let's see what's happening here. While context.running, node pointer execute context. Oh, I know why. Parser.y. When we get this, we don't want to do this. We want to say nodes dot pushback new command quit. Why doesn't it like it? Nodes. I don't know why the syntax highlighting doesn't work all the time in this. Nodes dot pushback new command quit. I got the semicolon in the wrong place. Nope. Invalid new expression abstract class command quit. Command quit shouldn't be an abstract class. Virtual void execute. Oh, I didn't implement toString. Yeah, so there's no value to printing out this toString, so we can just take that out. Oh, we got to return something though. Return that. Now it works. Okay. Go back to here. Quit. Goodbye. Okay. It's quitting. We can go 3 plus 2 times 7 divided by 4. And it comes out 6. We type quit. Okay, so that's working. All right. So yeah, so it's pretty straightforward, right? The parser, when it finds that quit command, it creates a command quit, puts it into the nodes. When we come down here, it takes all those nodes and it adds them to our result, and it returns that result. And we can process through them. Now there is one little problem with this. We need to really be cleaning up those nodes. See, we're using new, right? So we want to get rid of those nodes when we're done with them. So for any given thing, so they've been cleared out of here, and we now have possession over here. We could delete them over here, but because they are in this module where they're created, what I'm going to do is I'm going to create another function up here called void cleanup, and it's going to take a result, and all it's going to do is go for auto node colon result dot get nodes, It's going to go delete node. And so we should call this cleanup function from over here when we're done with all those nodes. So this is in main. We've executed them all, and this is the last thing we should do. We should call cleanup. We should call cleanup result. And we need that, darn it, cleanup result. We need this up here as an extern. And we can put these in a header file or something, but there's no need for it here. Cleanup result. Let's make sure it doesn't like seg fault or anything. What doesn't it like? Oh, semicolon. Nope, that wasn't the only thing. Where are we here? Oh, semicolon here too. There we go. Let's go back here. 3 plus 4. Type in some garbage, parse error, type in quit, goodbye, and it didn't seem to error out. It cleaned up those nodes. So those are the top level nodes. If there's a tree under them, we'll have to make sure that we clean up the whole tree. Each node will be responsible for its children, and it will, when its destructor is called, it will clean up those children. So we'll make sure we clean out all of the newed up pointers in this system as we go. So yeah, that's I think going to be it for this video. Let me double check the time. That's about 17 minutes. So that's pretty close to my usual time. So we now have a way to create commands, and we can create more commands, and they can have parameters. So you can type in a command like go to room, go to some room name or whatever, and the name of that room would be a parameter to the command. And so that go command would take a parameter, which room, and the compiler will fix that in there so that when we execute that command in the context, which this context up here will ultimately have like a list of rooms, a list of players, and other stuff in there. And the list of players is important because we'll eventually set up networking, and we'll make this into a server, and you'll be able to connect into it with a client, and we'll work all that out. Some commands will work in the client, some will have to be on the server. We'll have to have security, do cyber security and all that. So we'll work through all that as we build this up. Before we can really create any more commands, though, we're going to need some low-level stuff, and that's going to be in future videos. So thanks for watching. I really appreciate it. If you liked the video, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video. Thanks for watching.